The task of finding the K family's faulty gene was given to a young geneticist from Oxford, Simon Fisher.
When you start searching for something like this, you have no idea where this damaged gene may lie, or even if there really is a gene involved. So it's really pot luck when you start out whether you're going to find anything or not. The first stage was to collect all the DNA samples from everyone who was affected and unaffected in the family, and then we analysed this DNA looking for sections of chromosomes that were inherited by all the affected people but not by the unaffected people. And this enabled us to zoom in on one section, which was on chromosome 7, where we thought the damaged gene must lie. And this is quite a big step because we were able to exclude maybe 90–95% of the genome. There was very strong evidence from what we'd done so far that there really was something there. There was something lurking inside there. So I kind of had a gut feeling that we would find it eventually.
In the late 90s, Fisher's team had a breakthrough. They discovered an unrelated boy with the same speech disorder. His name was Christian Stark.
Something goes matter with my voice because my brain is trolling me not to talk very well. My brain and that. I get mixed up. I do. I get really mixed up because I have this kind of effusion with me about effusion. Is that right? Yeah, it is.
Who's going first this time?
Me.
Go on then.
It's something that eats cheese. It's not a rat or a hamster or it's a bit like it's a kind of, it's slow.
Young Christian's linguistic problems are remarkably similar to those of the K family. Sure enough, when his genome was analyzed, he too had an abnormal chromosome 7. But in his case, the chromosome was broken at one particular gene. After 5 years of searching, geneticists had found what they were looking for.
Christian Stark's DNA was the key to finding the faulty gene. It was rather like finding a convenient bookmark that flagged not only the right book, but the exact location of the printer's error. The faulty gene had been found. It was called FOXP2.
FOXP2 is a very special kind of gene. It encodes a protein that binds to DNA. In doing so, it turns many other genes on and off. It's a master control switch, and when it's faulty, lots of things go wrong. Given the parallels between Christian Stark, the K family, and Broca's patient Monsieur Le Borgne, it's clear that FOXP2 directly affects Broca's area. As such, it controls our ability to articulate words and use grammar. Human language is so complex that it must have needed the evolution of many genes. But FOXP2 is the first we've found. Other animals have the same gene. Chimps certainly do. But at some point in our recent evolutionary past, our ancestors acquired a uniquely human version of the gene. One that probably helped us talk. And as the genes for language assembled in our genome, everything changed. For millions of years, our ancestors had been cultural conservatives. They'd worked out how to make simple stone tools and, having done so, stuck with what they had. But with the evolution of language, they became cultural radicals. Painting caves, making ornaments, inventing new tools. Archaeologists call it the Great Leap Forward. This isn't hyperbole. We've gone from stone tools to mobile phones in merely 40,000 years. The invention of culture was a new way of transmitting information. All animals transmit genetic information to their offspring, but humans also transmit cultural information. We transmit memes.
The word meme sounds rather odd, but it's just a unit of culture. An idea, any idea that one person gets from another. And like genes, some memes spread and flourish while others go extinct. Their fates dictated by a culture red in tooth and claw.
A meme is any kind of information that is copied in culture. So whenever imitation or copying in culture goes on, that's memes being passed on. And that includes everything from the really important things like financial institutions, scientific theories, wearing clothes, to trivial things like, tying your scarf in a particular way or wearing a baseball cap back to front. They're all memes, the whole lot. In modern advanced societies, we are bombarded with memes from the moment we wake up. So our job as meme machines is really to be selective imitators, constantly having to choose which bits are we going to remember, which bits are we going to pass on.
A modern bookshop is a mimetic battlefield. Each year, thousands of new books are published, all competing for limited space in our brains. We have to make choices about which books to buy and read. And one way we do that is by buying what other people are buying.
Think about bestsellers. Are they really so good? It would be lovely to believe that we buy the books that we do based upon their literary merit, but sadly it isn't so. Bestsellers are largely an example of the madness of crowds. Some people buy a book. It gets noticed, it gets on the bestseller list. More people buy it. A chain reaction ensues. And before you know it, the thing has spread through the population like a virus.
Social psychologists have long recognized that humans have an innate need to copy and conform. There are classic experiments that demonstrate it.
Your task will be simply to look at the line here on the left and indicate which of the three lines on the right is equal to it in length. If you think the correct answer...
In this test, the volunteer doesn't know that everyone else in the room is an actor and has been primed to give the wrong answers.
You'll be third and so on. Okay, let's begin with the first set of...
Will he believe his own eyes or conform to the group?
1. 1. 1.
2.
1. 3. 3.
3.
3.
On average, a third of people in such tests conform to the views of the group.
3.
3.